continued. I do want to, before I get into Venn diagrams or into tree diagrams, I want to refer you back to something similar to what we were talking about yesterday, but written a little bit different format than our questions yesterday. So yesterday we had a table and you had to answer the probabilities looking at a table. Just going to change it up a little bit, okay, and see if we can still figure out what we can do. All right? So I am actually going to start right off the bat with example number 1. Alright, so in example number 1, according to the Red Cross, so they say, 45% of our population has type O blood. And they also say that 40% has type A. 11% has type B. And we're going to say 4%, make sure we get 100 there, 4% is AB. Now we're not getting into whether it's positive, AB positive, or anything like that. We're just talking about the type of blood, right? Okay, so using those ideas, or those percentages, we're going to just answer a couple probabilities. So what if I said, if 2 people are chosen at random. Whoops, I can't spell. Sorry. Random. I left out my N. I want to know, what is the probability both are O? So when you think about this, you say, okay, well, I know the first one is O, so I'm going to put that as 0.45. Then if I'm thinking about the second one, it's like saying, and the second one is also 0.45. So what do you think we're going to do with those 2 wonderful numbers? We're going to multiply them. Okay. So you grab your calculator for me. Tell me what's the probability that choosing 2 at random? 0.205? All right. Okay. What if I said that out of the 2 we're choosing, the probability that neither is A? So then what's the probability the first one's not A? 0.6, right? And what's the probability the second one's not A? 0.6. So when we multiply those, we get 0.36. Okay, now here's where I'm going to step it up a little bit. Well, here's A. They say 40% of the population is A. So to not be A is the opposite of that, the 60% that's left over. Do you want me to say that differently? Okay, just a minute. So if A is 40%, for it not to be A means I take 1 and subtract my 0.4. Because that tells me everybody else other than that 40%. And that gives us 0.6. Okay? So anytime you see the word not, we want to subtract it from 1. All right, so here's the one I'm going to make this a little bit tougher. What is the probability that both are the same? So let's talk about this. How do you think we can calculate that both are the same? Well, what do you guys think? Yeah. So maybe they both are O, or they're both A, or they're both B, or they're both AB. What do you think, Annika? You're close, kind of. You multiply the pairs. And then what did I just say when I was saying, so maybe they're both O, or they're both A, or, so once we find the probabilities of the pairs, then we're going to add them. Exactly. So we're actually going to take the probability of the O's, were 0.45, times 0.45, plus the probabilities of the A's were 0.4 times 0.4, plus the probability of the B's was 0.11 times 0.11, plus the probability of AB, 0.04 times 0.04. You should get 0.3762. 0.3762. Try again. So for this one, when we did this one, that was 0.2025. This one would be 0.16. This one should be and this one should be 0.0016. And you can add them all that way too. So let's kind of discuss it a little bit. So the first probability we did was the probability both of them were O. And we got the probability was about 20%, right? A little more than 20%. Why is it that this probability is higher? Exactly. We now have 4 different options, which has to increase our probability, right? They're not great options, but they are options, so it has to increase it. And that's why we add them all together. It's not a whole lot higher, but it's still. Okay? Probability is so much fun. Uh-huh. Okay. All right, so I wanted to show you this one because you do have a couple in your homework that are kind of along the same line where you got to think about how can I show this probability, okay? Awesome. Let's move on to Venn diagrams. What do you think? All right, in a Venn diagram. Remember in a Venn diagram, you have 2 circles that overlap, right? In that, if we make the first circle A and the second circle B, this section in the middle is AB. Yes, it's both of them together. Now, is it A times B, A plus B? What is it in the middle? A times B. I think it's multiply. So we're going to figure this out. So this part of the circle will be probability of A. This part of the circle is probability of B. This part of the circle is going to be our probability that A and B occur. We're going to write it that way. And do you guys remember, what was the outside? Yeah, outside of those 3 pieces. Well, back in Algebra 1, do you guys remember when we did Venn diagrams? And, of course, outside was what we called the complement. They're the ones that we didn't want. They were the ones that weren't included anywhere. So they didn't fit. So out here is the probability of not happening. Okay? So we're going to go with example number 2. Whoops. Example number 2. On example number 2, how about if I tell you, and we're not going to put it into a real life situation yet, let's just kind of start at the beginning. Let's say A and B are events. The probability of A is going to be 0.7. The probability of B is going to be 0.4. The probability of A and B is actually going to equal 0.2. And the probability, actually, let's just leave the remaining probability, is what's left over. So, let's start with this. We're going to start by 1, drawing a Venn diagram. Draw our 2 circles. This is going to be my A, this is my B. Now, here's the thing. When you get your probability, the A and B together is that middle section, right? So I'm going to put my 0.2 right here in the middle. Okay, then when it says the probability of A is 0.7, it's that whole circle is 0.7. So what goes in the outside portion of A? 0.5, awesome. So this is 0.5. Over here, this whole circle is 0.4, so it goes on the outside. 0.2. And then what goes on the outside of both of those circles? 0.1. How did we get 0.1 on the outside? Yes, 1 minus everything else we had. Very good. Okay. So, move my. Here are the different things you're given, right? We started with the and because that's the middle part. It's kind of where they overlap and they both occur. Okay, they both are happening. So we put 0.2 in the middle. Okay. Then this whole circle is A. Well, A is 0.7. We already have a 0.2 there, so the remaining part for this part is 0.5. Because this adds to 0.7. Okay? So then the same thing over here. This whole B adds to 0.4. And then when we added all of this up, we got 0.9. So that means we're still missing 0.1. And that's why it's outside the Venn diagram. All right? Okay. All right, so let's start with what is the probability using our Venn diagram here. I want the probability that A occurs, but B does not. It is, or 0.5, we're just going to say, right? Take it right out of that Venn diagram. A occurs, but B does not. So we don't want the overlapping part where both of them happen. We just want A. All right, how about the probability that neither A or B occur? 0.1, good. How about what's the probability of A or B? 0.9. I agree. So if it's saying either A or B, it can be any of the A's or it can be the B, but you can't use the overlapping twice, right? So really, we just added everything that was in here. We took our A's that were just A's, took our B's that were just B's, and we took our overlapping in the middle. Gave us 0.9. Questions so far? How are we doing? This is okay? Yeah. All right, so then let's move past the Venn diagram and do a tree diagram. Yeah. All right. All right, so when we talk about tree diagrams, a tree diagram actually has limbs that are going to work together. Okay? When we do a tree diagram, we typically like to start, usually it's just two limbs that are starting off, or two branches, so to speak, right? And then those two branches will branch off. And depending on the different probabilities of different things happening, they could branch off again. This is what we call a tree diagram when we start doing them. Okay? So I think when we get, for a tree diagram, it might just be easiest for us to do an example of it so you can see how it applies. The one thing I want to tell you about it is that you're always multiply, there we go, the limb. So I want you to keep that in mind when we go to start doing our probabilities. All right, so I'm going to give you a little bit. Here's example number 3. Oops. Well, somebody's phone's really helping out today. All right, example number 3. I'm going to do a little bit of writing. Sorry about this. If the school serves chicken, there is a 70% chance they will serve corn. All right, so that's the first part. If they do not, serve chicken. I'm going to add that in here. You don't have to write that if you don't want to. Serve chicken. There is a 30% chance they will serve corn. Seriously? All right. I'm going to add one more thing. You ready? Last thing we're going to add. Chicken is served 1 in 5 days. All right. So now, before I start doing probabilities, we are going to actually draw out our tree diagram to help us with it.
So chicken's on top.
Sure. You want chicken up here?
Yeah.
Chick. And down here, let's go with no chicken. No chick. So, what's the probability you're going to have chicken today? Oh, no. 20%. 20%. 0.2. That means what's the chance you're not going to have chicken today?
0.8.
Yeah, 0.8. All right, now we're going to do 2 more branches. Oh, maybe, if it lets me try again. Hold on. Sorry, guys. So then I'm going to do 2 more branches here and 2 more branches here. Now, obviously, if we're getting chicken, then we also got to talk about whether we have corn. So our branches at the top, we've got corn or no corn. Same thing down here in my branches. I've got to have corn and no corn. So let's go back up to here. When we are having chicken, what's the probability we're going to have corn? 0.7. So what's the chances we don't have corn when we're having chicken? 0.3. Good. Okay. What's the probability when we're not having chicken that we're having corn? So what's the probability that we... 0.7. Good. Okay. So here's our tree diagram. We've just kind of broken it up so we can see it really easy what's happening with each one, right? So now if I were to say to you, what's the probability that we have chicken but no corn? So I want probability we have chicken but no corn. So we're going to take our chicken, which is 0.2, and times it by our no corn, which is 0.3. 0.06. What's actually the probability of not having chicken, not chick, but corn? Okay, so not chicken is 0.8, but we are having corn, which is 0.3, so the probability would be 0.24. Can you see how a tree diagram can kind of help you figure out which direction things can go? Okay. All right, let me see real quick. I only gave you 11 problems for homework, and I want to make sure you have some time to do them because we're going to have some discussion, I'm sure, going on. I do want to mention, they say the word conditional probability, so let's just talk about that very quickly. Conditional. Probability. Conditional probability is usually written like this. The probability of B if A is happening, right? So if you see that notation anytime it's talking about conditional probability, it's actually the probability of A and B, so both of them occurring together, and we multiply them, divided by the probability of A. So anytime you see this notation, the second number is the probability, and it's in the bottom. Do you know what I mean? That's what you're dividing by. Okay? So just in case you see something along that line. Huh? Well, if this was written, if I had the probability of this written that way, and then this is still, the top is still going to be the same, A and B, because they multiply together, but then you're going to divide by the probability of B. Yeah. Okay? So conditional just means it's depending on what you're taking the group from. Do you know what I mean? It's depending on something else. So it's conditioned. It's got different things going on. All right, so I wanted to throw that out there because you're going to see that word a couple times, but it's going to be fine. All right? It's all right. We got this. Okay, so I want everybody to turn to 29 in the first one. 29 and 31, it says right in the directions for those of you that tend to miss the directions. Some people tend to do that. I wanted to point out that it says for 29 to use a tree diagram. Okay? In 29, it starts off by telling you the school cafeteria has decided to serve meatloaf. Not the meatloaf, I know. And with the meatloaf, they're serving peas. All right, so it's very, very close to what we just talked about. But then you got to decide. There's 3 different probabilities they want you to find. Okay? All right.